Hello everyone, this is Mitch 2 reporting for duty. Today we will be learning about trig substitution. Trig substitution is used when an integral contains one of the following expressions. The square root of a squared, oh no. The square root of a squared minus x squared, the square root of a squared plus x squared, or the square root of x squared minus a squared. This is basically like what we've been learning earlier in the week with 7.2, but you will be using these instead of other things you've learned for these separate ones. It's pretty self-explanatory. I'm not going to go through these, but these are just the rules that you should follow, and we'll go over that while we are doing the actual problem. Okay, so number one. What we're going to start with is identifying which trig substitution to use. So, obviously, this is represents one of these three, and it would be the first one. So we're going to star that. The trig substitution we'd use is x equals a sine of theta. But first, what we need to find is a, x, and dx. So for starters, if this is our a squared, then we just take the square root of 16 and a will be 4. So what we take is x equals a sine of theta, which is the new material, and we just plug in 4 for a. So x equals 4 sine of theta. So once we find x, we just go for the dx, which is 4 cosine of theta. So our next step would be to substitute for x and dx. So all you're doing is plugging in your x, your dx, into the integral. So you just boop. Okay, so x is 4 sine of theta. And since it's x squared, just square it, times the square root of 16 minus 4 sine of theta squared. Don't forget, since there's a dx here, got that nice purple highlighter, you just multiply it by the dx, which is what we found. It's 4 cosine of theta. Simplify that all. We got 1 over, oh wait, awkward. No, we don't. I lied to you. We have 4 cosine of theta all over 4 sine of theta squared times the square root of 16. Oh, we could just go ahead and simplify this right away. So 4 sine of theta squared would be 16 sine squared of theta times the square root of 16 minus, and again, we're just simplifying this, is 16 sine squared of theta. What we need to do next is just take out the common factors. So you have a 4 and a 16. This goes away, and this becomes 4. Basic math, what? So, and this is all times that. So you got cosine of theta over 4 sine squared theta times, take out a 16, and you've got 1 minus sine squared of theta. This is a really important step of the entire process here. Oh, wait, I just want to change my color. Okay. Okay, this is happening. Boom. This is one of the substitutions we learned earlier in the week. So 1 minus sine squared theta is the same as cosine squared. So all we're doing here is, oh, I don't want yellow. Yellow is no bueno. Okay, wait. Should I use red? I'll go with the red. Okay. We're just, oh my god. Oh my god, I can't right now. It won't go. I want red. That's all I want. Okay. I'm really sorry, listener. Okay. Cosine of theta times 4 sine squared of theta square root of 16 cosine squared theta times d theta. Okay, we're going down. I'm yelling timber. So I'm just going over here. I didn't even touch the screen. Okay. I'm just going back over here, so, um, simplifying is really what the whole process is here, so don't worry about it. Nothing too complicated. If you're looking at the square root of 16, you just got times 4. Square root of cosine squared is cosine of theta. And we've got common factors. Cosines cancel out. We've got 1 over 16 sine squared theta. And 1 over sine is cosecant. So all I gotta do is make that cosecant squared. And put the 1 over 16 out in front just to make it easier for yourself. And this is the last step of this. Wow, look at my writing. It just got bigger and bigger. This is the last step of this part. So if you're going to take the antiderivative of cosecant squared, it's negative cotangent theta. So got to put the negative out in front. 1/16 cotangent theta. And don't forget the c. So this is not your final answer. Just so you know, you can never have a theta in your final answer. It says it up here. It's in terms of x, so this isn't your last part. What we do now is we draw the pictures. Best part of the entire thing. We're going to go back up here. We are using this part, the x equals a sine of theta. So really 4 sine. And we go down. We use SOHCAHTOA. If you were all in class on Friday, we saw it all around the board. It's very important. Can't forget it. Boom, boom, boom. Okay. So if this is our angle and our equation is x equals... No, stop it. X equals 4 sine of theta. We're going to isolate sine. So sine of theta equals x over 4. And sine of theta equals opposite over hypotenuse. So if this is our angle, x is the opposite, and 4 is the hypotenuse. So in order to find the last side here, you could do the Pythagorean theorem, but it's actually just easier. It's whatever here that you're trying to find with these expressions, awkward, it'll just be that, so don't worry about it. Oh, stop. I really hate everything. Hi. What's this?
Are you recording?
I'm recording. Sorry about that. We are back with calculus. Here we have, I said that you could just go with the thing that we were trying to find earlier, which is square root of 16 minus x squared. That's our third side. We're trying to find here, since we can't have theta in our final answer, cotangent of theta, we have to find that. And cotangent, you look up at tangent. Cotangent is adjacent over opposite. You guys should know that. So adjacent is square root of 16 minus x squared over opposite, which is x. So now we're at the final step. So yay, congratulations. Can I use this guy? Can you see that? Yeah, not really. La 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 la. Okay. We're just going down from here. We're using this formula here and what we found here. So we're just plugging in this for cotangent of theta. You got negative 1 over 16 times square root of 16 minus x squared all over x. Can't forget the c. And simplify that, you've got negative square root of 16 minus x squared all over 16x plus c. Yay! Calculus. Yeah. Ooh!